Hello everyone, am I audible? Hello? Yeah, cool. How's everyone doing? Were you guys able to revise the last lecture? Were you guys able to revise the last lecture? You were? That's great to know. Cool. So before we start, any question from yesterday's lecture? Anybody has any doubt, any question, any comment from what we discussed yesterday? Or in fact, even before that, any comment from those topics or the solutions that we discussed till yesterday? Cool. It seems there is no such comment. So we are going to now revision helped a lot. Yeah, Chauhan Prithvi, that's absolutely very right. If you revise, you are going to learn a lot, and only then you will be able to appreciate the entirety of the things that we discussed. Right? Santan says. Are message queues less costly than DB calls? Since we are still making 2000 message queues calls in the last approach. Makes sense. So writing in a DB, in a relational DB, is going to be much more costlier than writing in a pushing message in a message queue. Okay, Santan? Because in a relational database, you actually end up doing a lot of constraint satisfaction. So you end up doing a lot of things which takes a lot of time. You want to make sure that all the constraints that you have defined on a relational database are satisfied. Also, as Moise rightly points out, that is more of a disk write, and most of the message queues it would not be, right? So we are going to discuss that also when we discuss message queues. But yes, it's relatively cheaper to insert in a message queue than insert in a DB. Okay. Santhan, doesn't make sense. No, Sukanya, you did not. Sankalp says now pushing to queue is basically writing. Yeah. Pushing to queue is is writing, right? Cool. So we discussed, yeah, discuss levels of caches. Okay. So what exactly do you want to discuss there, Chauhan? Try building a solution, and then maybe if you still have some doubt, you can ask that question, Chauhan. Cool. So we discussed yesterday that we would want to have a system which is not going to overwhelm, overwhelm our system, right? We have want, okay, video is breaking. Is the video breaking for everybody? Is only the video breaking? Also, the voice is also breaking. The voice is breaking. Okay. So let me just try to stop my video. Maybe it will improve now. So I have stopped sharing my video. Maybe it should improve. Has it improved, guys? Shit, man. So actually, we started the class late because we still had. I had some internet connectivity issues, but it's still here. Uh, just a minute. Is it better now? Is it better now by any chance? It's better, right? Cool. Yeah. So, yeah. So we would again do that capacity estimation. Once we do that capacity estimation, then we should be able to appreciate the depth of the problem, and then we can see how we should actually go about solving it, right? So what options are out of the picture and what options makes the most sense, right? So we discussed about Facebook that let's assume daily active users of Facebook. What did we assume? 200 million, 400 million? Do you guys remember that? 400. Okay. So we assume 400 million are daily active users of Facebook. Then secondly, we started all the users. All the users of Facebook we assumed to be 2 billion, if I'm not wrong. Then we assumed that every user is going to make a post every day. How many posts did we assume per day per user? So we assumed 10. Is that right? 2 would be, or 10. I don't think we would have assumed 10. I think we should have assumed 2. So we assumed 2 per user per day. That would essentially that day. Does that make sense, everybody? I have 800 million posts per day, right? Is it still breaking? Let me just try switching off my router and reconnecting. Please hold on for a couple of minutes, okay? Please don't go anywhere. I will just try to. Guys, is it better now? Yep. I hope it remains better. Right. So we are going to see 800 million posts every day. And after that, we also discussed how many friends do you assume every person on average to have, right? Or in better terms, I can say how many people do you think would be affected by every post that is being made? What was the assumption there, guys? 2000. Okay. So our assumption is that every post, if affects the news feed of 2000 people. Okay. So now if every post affects the news feed of 2000 people, essentially if you want to have any solution in which you store the aggregated news feeds, you would assume, you would understand that every post would essentially mean 2000 writes. Does that make sense, everybody? Does that make sense? So 800 million into 2000. So these many writes, if I want to have any aggregated solution, this in itself will tell you that maybe if I can avoid this, I should be trying to avoid it, right? So what does it become? It becomes, how much is this? How many, how many writes is this, people? Nobody's replying. Yep. So it's 16 into 10 power 3 million. Does that make it 16 billion? Yeah. 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 So it would be 16,000 million posts per day, not posts, writes per day. So it makes sense that this is going to be very, very this is not going to be simple. This is not going to be easy to be managed. Okay, cool. So once this is done, we also computed the QPS thing. Let's not do that again, but it's very, very important to compute the numbers in terms of per second, that is in terms of QPS. For now, I would want to estimate the storage as well. Okay, I would want to estimate the storage as well. Okay, or let's just wait for estimating storage. Let's actually figure out that yes, aggregated solutions are not the best. Let's try to actually figure out a solution which does not aggregate. Okay, so for that, I would propose a solution and you guys tell me, does it look better? Does it look nice or not? Narayan asks, can we have user post table in separate tables, DBs? That will be reduce the number of DB hits. Can we have user post tables in separate DBs? Narayan, do you want me to unmute you? I did not get what exactly you are saying. Narayan, can I unmute you? Hey, Narayan. Okay, I will wait for you. Okay, sure. Yeah, please go on.
Yeah, hi. I mean to say that can we have like right now in our DBs, so we were storing user information in DBs and then we were doing consistent hashing and storing the information there. So can we have just like our DBs contain user post information, user post table in DBs separately, so that our DB just contains the user post table, and so that we can have lot of entries in a particular DB regarding this table?
No, so we were already we were assuming that we have that users post table stored in the DBs, and we said that these would be sharded, right? So this table would be sharded. That is for some users, the table would be here. Some users, the information would be here, and so on and so forth. This is what we assume, right, Narayan?
Okay, okay,
Right.
okay, okay. So we are already assuming that.
Yeah, it's
So
already
it
sharded.
means other information related to the user is not there in the same DB. That's
In
what I
not
meant.
there in this table, not there is in this
Huh.
table. That table would again be sharded. That may or may not be in the same box. Okay.
Okay.
Does it make sense, Narayan?
Yes, yes.
Okay, thank you. Yeah, cool. So let's come up with a design in which we do not need to aggregate. Okay, so let's come up with that kind of a design. You have this client here. Let's assume for now that the client is wanting to write a post. Okay, the client wants to write a post. Let's see how the control flow would go if we do not want to aggregate data. So when the client wants to write a post, it will call the write API. It will hit the load balancer. The load balancer will take him to the specific box that client is at. And now when you write a post, I would be saying that user ID to post should actually be persisted in the DB where that client belongs to. Does that make sense? Because we want to persist the post, we do not want it to be lost at all. It's very important that we actually persist it to the storage. Okay, so user to post, we have persisted in the storage. Now once I've persisted it in the storage, I would say let's actually store that also in a global cache. So let's have a global intermediate cache which only stores the user ID to post, comma timestamp. Does it make sense, people? So what we are caching? We are caching all the recently added posts. Okay. So now Moez asks a very good question. Moez says that are you going to actually cache user ID comma post, or is it going to be post ID? Right. So let's actually discuss that. Let's actually discuss what's the difference between storing user ID or a post ID or post. So do you guys appreciate that post ID would be of a few bytes and post would be of 500, 600 bytes? There would be a difference of a factor of 100, more than a factor of 100 between the two. Now, do you think that not storing the post in the cache is going to be helpful? No, because you are at the end serving the post, right? So post also needs to be fetched relatively quicker, you cannot expect to fetch the post from the DBs. Does that make sense to everybody? So there are 2 points here. First of all, yes, post ID and post, there is a great difference between the amount of storage that you would require to store post ID versus the amount of storage that you would require to store post, point 1. But point 2, only storing the post ID in the cache is not going to speed up your process because you are actually serving the posts to the user. Does it make sense? Okay. Now, the post would compromise of some text and some medium, that is some images or some videos. We know that we are going to serve the images and the videos through the CDNs in most of the cases. The actual, the first copy of the post and the video would be stored in a file storage. This we all know. But even for the text, we want it to be outside of the DB as well, a copy outside of the DB as well, so that we can show it easily. Now, the only point that remains is should. So we all understand that post ka content should definitely be in the cache. Does that make sense to everybody? Post ka content should definitely be in the cache. Now, the only question that remains is, should that post ka content be in this cache, or should it be post ID and we have a decoupled cache where we have post ID to post? Does it make sense? Does it make some sense, guys? There are 2 ways to go about it now. One way is that let's have the post in the first cache itself. The second way is let's decouple them and have the post ID to post mapping in a separate cache. Now, in case of Facebook, okay, in case of Facebook, the point is that you know that every post can actually be shared by multiple people. Does that make sense? So let's say Beshali made a post and I want to share that post. And I can share that post by adding a content of my own as well. Does that make sense? So I can actually share that post by adding a content of myself as well. So if I end up not decoupling it, you would realize that I am storing a lot of duplicate data in the global cache. Does it make sense or does it not make sense? Because you can actually have, okay, I am repeating it. In a Facebook Lite system, you can see that let's say somebody makes a post and you can make a share of that post. You can share that post, and while sharing, you can add some content yourself as well. Does that make sense, Vishali? A shared post is not a direct copy of a post. It's a copy plus some added content as well, right? Had it just been a copy, you could have maintained only one storage and only kept a pointer, right? But just because you can modify that copy, that is, you can add upon that copy, now it becomes a little better to actually decouple it and have a separate cache which has post ID to post. Does it make sense to everybody? Yeah. So there should be one LRU cache which happens to be the cache for user to post comma time. Okay. So I will just magnify this cache from here and bring it here. Okay. So I am talking about the global intermediate cache. All I am storing in this cache is the moment somebody makes a post in the entire world. It's a global cache, right? The moment somebody makes a post in the entire world, I am going to add a ID, which is going to be user, comma, post ID, user ID, comma, post ID, comma, timestamp. Does it make sense, everybody? Now this cache can actually be a LRU cache. Does a LRU cache make sense? What is LRU? The data which was accessed the latest is more important to you. Does that make more sense? So a post which you feel people are viewing in the world, is that post more important to you or not? Is that post more important to you or not? It is, right? So a post which is trending, a post which people are viewing, a post which was accessed the recently, that post can be assumed to be an important post, and I would want to store that. Okay, cool. Now, so the key of this cache will be user ID, and the value of this cache would be a tuple, which would be post ID, comma timestamp. Cool. Now, once this is done, we have another cache that we discussed, which happens to be the post ID, comma post cache. Does it make sense? Now let's see how does the entire control flow look. Okay. Now let's see how does the entire control flow look. For writing a post, what will happen? Client will call a write post API, send the content of the post. The load balancer will pick it up, send it to one particular box where the computing of that particular client or that particular user happens. Then you will actually process that data to a particular DB and also write it to this cache. Okay, so this is how a write is happening. Okay, so for every write, you're only doing one single, basically one write in the DB and one write in the cache. So you do not have any factor of 2000 or 1000 in this kind of a scenario. Now let's see how does a retrieve news feed happen, right? How does, okay, so Shubham says also to the other global cache. That makes sense. So you are also going to write, add it to here as well. Okay. What about intermediate write? Archit, I did not get your question. Do you want me to unmute you? What about intermediate write? So basically there are three writes, right? Two writes to the cache and one write to the DB. Does that answer your question, Archit? Okay, it does. Cool. Is it one transaction? Good question, Neeraj. I am going to describe that. What is a separate cache? What is the separate cache with post ID, comma post cache called? It's again a global cache, and that's it. So are we going to write to cache instantaneously or only when request arises? That's a good question, Deepika. And there are, as discussed in some previous classes, there are three ways to solve it, right? So Neeraj and Deepika both are asking the same question. Let's answer that. So one way that we discussed was that you first write things to the DB because you want it to be persisted. And whenever you see the first request, so you are going to read from the cache. Okay. So what you can say that you can write to the DB, and after some time, maybe in a grouped fashion, you are going to persist it to a cache as well. So you just write to the DB and tell the person that, yes, I have written it. And then at your own leisurely time, update it to the cache. This is one possibility. The second possibility that you have is that you can say that I will insert both in the cache and the DB, and only then I will tell the user that yes, both things have happened. Does it make sense? Now there is a third approach as well. The third approach is that you only write to the cache and tell the user that yes, I have written your post, and then at your own leisurely time, write to the DB. Okay. Now the point is, if you go with the first approach, that you write to the DB only, and then at a fixed interval of time, update all the recent posts to the cache, right? If you at a fixed constant time interval of time update every new information from the DB to the cache, can you guys tell me the pros and the cons? The pro here is that the pro that is here is that the data is persisted. Does that make sense? If you write to the DB and do not write to the cache, write to the cache after every interval, after every, let's say, fixed interval. The pro is that you have persistence of data. The con would be that you would want to, so let's say I am making a post. So let's say I'm making a post on Facebook. I will not be given very less latency. Does that make sense? And is that even fine? So let's actually discuss it. It's a very, very interesting problem to discuss. So let's say you are making a post, Deepika, on Facebook. Okay. You wrote something and you're making a post. Are you fine with waiting for a, let's say, few seconds or maybe half a minute before your post goes online? Are you fine with that? Yes, I would say it's totally fine, right? Because if you are writing a post and you received a notification after 30 seconds, after 1 minute that your post is now live, that's a good feeling to have, right? Because you do not make posts all the time. So having some delay here, having some having some higher latency here is fine. On the other hand, would you be fine by saying that you made a post? I told you, hey Deepika, your post is live, but after some time I say, oh, oops, I just lost it. Is that a good design? Can you please repost it for me because I lost it, right? That's not a good design. So here, it's very, very important to make sure that the post is persistent. Even if there is some latency, it's fine, because understand the latency is not here for the person who's trying to read the post. Okay, I will describe that as well. The latency here is for the action when you are writing a post. Having some latency in these kind of applications for writing is totally acceptable. I hope this makes sense to everybody in the class. Does it? Right. Cool. The second approach that we discussed was that you write in the cache and write in the DB, and when both of them are done, only then tell a yes to the user. So is the post still persisted here in the second approach? So first approach has persistence. Does the second approach has persistence? Yes, this also has persistence. I said the first approach had some latency. Does the second approach also have some latency? Yes, it has the latency, but slightly more, slightly higher latency. Okay. But one thing that is better in the second approach than the first approach is that this ensures that the folks who are trying to load their news feed, they would be able to see your post relatively faster. What does that mean? I will just go through how the retrieve newsfeed is done, and then we will be able to appreciate it. Okay. So just let's hold our horses. Let's discuss that, and then we'll come back and see that why the second approach is slightly better than the first approach. Okay. Let's come to the third approach also. The third approach was that you simply write to the cache and send a yes to the user, and then persist to the DB somewhere down the line. The problem here would be it is not persistent. Okay. Okay. So Archit, do not say it's not consistent. So guys, do you know the difference between consistency and persistency? Or do you know the difference between whether it's consistent or persistent? So when we discussed the CAP theorem, we discussed consistency, availability, and partition tolerance. We never discussed persistence. Data persistence means that once you have written, it is not going to go away. Okay. In the third approach, the data may no longer be persistent because the cache can go bad, and you will lose out on that particular post. Yes, Deepika, writing to the cache is faster than writing to the DB. That's totally true. Okay, cool. Moez, it's not only about the eviction. It's not only about when you evict, then you're going to lose the data. You can very well write to the DB before you evict. That's totally fine. But the point is, the problem here is that what happens if the cache goes bad in between? Let's say you are syncing every data from cache to DB every, let's say, 5 minutes. What happens if the cache goes bad? Do you guys understand? Cache is just a memory. It's not a persistent thing in most of the cases. It's volatile, right? So what happens if the cache goes bad? You are going to lose out on that data. So what is the option here in the third approach then? The option here is that the cache should be persistent. There are persistent caches as well, but in those caches, the writes are slightly slower because you would have to persist somewhere, and persistence only happens when you write something to the disk. So yes, these writes are going to be slower. Does that make sense, everybody? Does cache servers also have redundancy? Yes, cache servers also have redundancy. Yes, they do have redundancy. We will discuss that. Is the third strategy used in any real life system? Vaishali, yes, this is very much used in real life systems. So I would tell you that let's assume maybe a gaming system. So you just made a very small move. Let's not assume it to be a chess gaming system. Let's assume it to be a massively multiplayer game. Let's say you are playing some PUBG kind of game. Are you with me? Yep. So let's say you are playing some massively multiplayer game online, and now maybe a very small action to persist that very small action is not very important. You can afford to once in a while lose some actions that you did, but making sure that your response time is very less, that is of the most importance. So you cannot just say that I am going to persist this data, write it to DB, only then tell the user that, hey man, yes, you moved one step forward. That would be a very bad design. Does that make sense to everybody? Yep. So yes, these things are also used. Okay. Cool. Now we have discussed the three ways of storing data in the cache and storing data in the DB as well. Now let's see how does my fetching a newsfeed is going to look like. Okay. Let's see how my fetching newsfeed is going to look like. This is my client. This is my load balancer. The load balancer interacts with so many app servers. We have a global cache here, which will be user ID to post ID, comma timestamp. We have another cache here, which will be post ID to post. And then we have these boxes. Right. Sankalp, you can revisit the previous lectures to figure that out, right? So that is just a definition. So we covered that extensively in one of the previous lectures. Just go through that lecture and you will figure out the definitions, right? Cool. So now if you want to fetch your newsfeed, so the client, let's say, makes a request to fetch a newsfeed, okay, and passes his or her user ID. Now what will happen? The load balancer will take you to the box where that user ID is being served, and to fetch the newsfeed, what will now happen? This box will communicate with the cache and make a query. Okay, what is the query like? The query is like this. You are going to make a fetch query in the cache, and this is what the fetch query is going to look like. Fetch from cache all the posts where the key belongs to my friends of a user that was given, and the updated time is less than k. Does that make sense, people? So what is going to happen? So first of all, let's try to understand that this fetch newsfeed is always going to contain a timestamp with it as well. Does it make sense? So let's say Beshali or let's say Lokesh is using Facebook from his app. Even when you are offline, when you open your app, do you see some posts already there? Do you see some posts already there when you open your Facebook app? Even when you are offline, do you see some posts already there? How are those posts being populated? Can you guys give it a guess? Right. So it's from client side cache. So at the client, you have a client side cache. From the client side cache, you are seeing the posts that you fetched some time ago. From those posts, can you look at the timestamp of the last post that you had? Can your client store that data? That I have received all the posts which were up till this timestamp. So whenever you are making a call to fetch newsfeed, you can pass that timestamp as well. Is that right or no? Not. Can you actually pass that? Yes. The moment you pass that timestamp, now the box is going to make a query, and this K is going to be that timestamp that you passed. So your client told me that I have all the posts till 3 p.m., 3:02 p.m. itne seconds. I have all the posts till that point in time. You give me the latest posts. So what will happen? My box will simply make a call to the cache and have this kind of a fetch request. We are going to fetch everything from the cache where the key belongs to the friends of mine. This friends can be generalized by saying that everybody that I'm following, every topic that I'm following, or everything that I'm interested in, and where the updated time is less than the time stamp that I received. Does that make sense, guys? Right. So now let's consider about the Facebook web application as well. So we discussed about Facebook app. When you actually hit the Facebook's website, do you see some pre-filled news feed? No, because you would not have cached that across sessions. Does that make sense, people? So if you are not online and you try to hit the Facebook website, are you going to see anything? People, have I lost you? No, you are not, right? So yes, there are going to be cases where you do not have anything cached at the client side. What happens then? In that case, you can start with a timestamp that you have given by default. So let's say by default you have defined that you are interested in the post which happened in the last 6 hours, right? So if you do not have any newsfeed at your end, you can just fetch for the data which happened to be in the last 6 hours. Does it make sense, guys? Now, do you see this to be a good strategy? When you are writing, you are just writing the basic information about post and who made that post. When you are reading, when you are retrieving the newsfeed, you are then doing the aggregations and generating the newsfeed on the fly. Is this better or not? Yes, this is better, because point one, you are having a lot less writes. You have saved on a lot less writes. You are saved on a lot of storage space. You have saved on a lot of random time that you were spending. Now you are only spending a time in generating a newsfeed when somebody actually asks for it. Does it make sense, guys? Does it make sense? You are only spending the time to generate a newsfeed when somebody is actually asking for it. Now a question would be that are we not doing recomputations? Right. Are we not doing recomputations? Do you think we are doing recomputations? So let's say Lokesh opened his app right now. He got the latest news feed. So whenever he comes back, he's going to again ask for a news feed. Or even if he did not quit the app, but even while on the app, he was constantly refreshing the app. Does it make sense, guys? So even when you are constantly refreshing the app, or even if you're not refreshing the app, but automatically your client can send a refresh request, let's say every 5 minutes or every 7 minutes or every 10 minutes. So you are going to recompute the news feed, but essentially you are only going to look at the feeds that you did not look before. Does that make sense? You're only going to look at the posts that you did not look before. Guys, is it making sense, or are you guys feeling lost? Okay, so let me just take a minute, because I feel that there are some people who are feeling lost. Makes sense, Sankalp. So Sankalp's question is that newsfeed read is going to be very, very intensive. So why we are aggregating at the read time and not aggregating before that? Sankalp has this question. So let me try to help you with that. So Sankalp, the final system that you are going to see is going to be something like this. Everybody please pay attention here. What is the problem and what is the solution there? So we have this client, the load balancer, all the app servers, and all the posts, latest posts here in this global cache. Now understand, this is not the only cache we have, but every time I compute a news feed on the fly, let's assume I also cache that news feed at my end. So let's assume there is an app server cache as well, which caches the latest news feed that was computed for that particular user. Does it make sense, Sankalp? So let's say you checked your news feed 2 hours ago, and just because you checked it, I would have computed your news feed. So I would have computed your news feed, and rather than only sending back to the client I would also cache that newsfeed at the app server. So if after some time you try to access Facebook from a different laptop, let's say you try to access Facebook from my laptop, you log into your account, we would serve you the first newsfeed which we computed for you 2 hours ago, rather than waiting for it to be generated on the fly. Does it make sense, Uncle? So the moment you log in, every time you are going to see some newsfeed. That newsfeed may not be the latest one, but after you spend some time, before even you notice it, your feed would be refreshed and the latest entries would be populated. Have you guys seen that happening yourself as well at Facebook? So do you guys see that? That the moment you open your app or the moment you open Facebook, you may see a feed which is looking slightly old, even when you are connected to the internet. You may be looking at a feed which looks slightly old, but before you notice, in a couple of seconds or in very small amount of time, you now start seeing the latest feed as well. Does it make sense to everybody? Right, Moise. So this is how you actually try to play with users' perception and make them realize that that the latency is very less, but actually the latency is slightly higher. Does it make sense, people? So using this combination of client-side cache, global cache, and app server cache, you make the user believe that yes, the things are responding very quickly. At the same time, you save on a lot of extra writes that you would have otherwise done, and also allow yourself to do very light newsfeed updates. What do we mean by that? So let's say Moise is constantly refreshing his Facebook feed. So let's say he refreshed a few seconds ago and he refreshed it again. If he refreshed it again, do you understand that this time this operation is going to be very, very light? Because I am just going to the cache and telling the cache, asking the cache for a timestamp, which is very, very nearby. So the cache is only going to reply with a very few posts, and this processing is going to be very fast. Does it make sense, people? So just because you are using these combination of these multiple caches, the client side cache, the app server cache, and the global cache, it gives a feeling that things are running very smoothly and very fast. How many of you appreciated what we just discussed? Do you guys appreciate this design? Look from the perspective of writing, look from the perspective of reading, you would see that this happens to be a very, very good design. And the latest that I know, this exactly is the design. Well, this not exactly. The Facebook's actual design looks very, very similar to this. Sankalp, okay, that's a very good question. I will take that up, but let me just try to answer some simpler questions before that. Okay. So Sukanya says, what if I never post new things, but still the newsfeed has to get updated? Okay, Sukanya, I will answer that. That's a confusion that I feel some of you might be having. The data, a lot of data will be there in the global cache. Okay, Nikhil. So Sankalp already asked that question, that how to estimate how many days of data can you store in the cache. I'm going to do that estimation with you. That's a very good question to ask. Sukanya now asks, are we making the call to get the post on post ID from cache in app server box after global cache sends result, or do we do that from the global cache only? Okay, Sukanya, this question is not clear. I will go through the flow again, and then I will unmute you and ask your question and try to answer it. Moise asked, do the global cache also follow master slave architecture? Okay, so okay, yes. So caches, you can totally configure that. You can have replications, redundancies at caches as well. Most of them do. And is it a master slave architecture, or is it just saying, yeah, it's basically, you can call any such architecture a master slave architecture. Yeah, it's one of the same thing. Yes, Moise, that's right. How does the flow happen in case of a shared post? Okay, Sohail, I will try to answer that as well. Cool. Any other doubts, anybody? Okay. So Vaishali says, yesterday we discussed message queues. Our final design does not use them. So that was also a flawed design due to the volume of writes. Exactly, Vaishali. The design that we discussed yesterday was using message queues. That is one possible design. You can do that, but that in Facebook's approach may not be the best possible design, right? In a big system, you will be actually using, for some cases, you will be using message queues as well. But this design for normal use cases happens to be the best design. Okay, Vishali? Because you would appreciate that here the problem of having so many rights is totally gone. You are not writing too many things. You are only doing things when they are actually required. You are not preemptively doing a lot of things, and at that scale doing preemptive things becomes very, very difficult. Does it make sense, everybody? Sure, we can do a walkthrough of that as well. Cool. So let me now do walkthroughs of simple posts, simple newsfeed retrieval, and then sharing a post. Okay, let's try to do the walkthroughs, and then we will take up some remaining questions, and then I will want to do some estimations, and then we will see how we can move forward. Maybe I would want to discuss a bit about data partitioning. Maybe I would want to discuss a bit about cold storages and so on and so forth. Cool. Yep. So, let's look at it, and let me try to draw it neatly this time around and not draw it as a randomly kuch bhi. So there is a client, right? There is a client. The client interacts with load balancer. The screen is struck. Okay, okay, okay. Uh, so many issues. Just a minute, guys. Is the screen visible now? Okay, just a minute. Is the screen visible now? Yes, good. Yeah. So we have a client, we have a load balancer. The load balancer would be interacting with app servers. Let me draw them neatly. Right. Now there is a cache that we have, a global cache. Okay. The global cache is going to have user ID mapped with post ID comma timestamp. We can actually not have a decoupled cache and only have user ID comma post and timestamp, but we discussed where does a decoupled thing make sense, right? So what we can do here now, we can have a different cache here, which is going to have post ID, post content, comma timestamp. This post content can actually have multiple things. This will have so many things, like let's say the parent post ID. So what is parent post ID? It can be -1 in cases of a post which is a new post, but if you are sharing something, so you can have a parent post ID as well. Does it make sense? So you can have a parent post ID. You can have some text associated with your post. You can have a timestamp. With that, you can have some links of resources. So let's say links of videos or photographs. Does it make sense, guys? So a post is actually a tuple of these things. Can you guys hear me? Nobody's responding. Yes, you can. Cool. So this is going to be another cache. Now you're going to have storage boxes here. So what all did we discuss here? Yes. So Nikhil says those links will be for S3 or CDN. That's a good question. That those links should be. You should actually store both the links. You should actually store the links for S3 as well and for CDN as well. But in case where you have a system where you know that these things are definitely going to be served by a CDN, you can only choose to have CDN links. So this is more of a practical question, Nikhil. It's not a theoretical question. That totally depends on the system that you're designing and the kind of coverage that you have from CDNs. And you can take a call whether you would want to store S3 links here in the cache or not want to store it. Does it make sense, Nikhil? Cool. Now, in these storages, okay, I think the screen is still again stuck, right? Screen is stuck again. क्या यार बहुत दिक्कत हो रही है इंटरनेट की. Just a minute. Let me see what I can do to. Yeah, I'm very sorry for this frequent disruption. Matlab, can't help it. Cool. Yep. So we have actually, yeah. So these are the storage boxes that we have. What all tables did we discuss? No screen. You can't see the screen. Oh, I can see the screen being shared. I don't know why you guys can't see it. Is it stuck or are you guys not able to see the screen? No screen. Yep. So let me try connecting with my mobile data. If that solves the problem, the probability of that solving the problem is very low, but let's just try doing that. Just let me know the moment you guys can see the screen. Are you guys able to hear me You guys can hear me, right? You guys can also see the screen. Cool. Let's see if this is better. Can you guys recall all the tables that we decided to store on the student table was? Is that right? Guys, can you hear me now? Uh, Let me just connect the iPad. Can you guys see the screen? Cool. So these are tables that we were talking about. One table that we had was user to friend mapping. Can you guys tell me the next tables as well? The other tables that that we wanted to store at the DBs. Can all of you tell me those tables? Then there was a user to post table. Does that make sense? User to post ID table, right? Then again, you are going to have a post ID to post table. Okay. What else? Did we have something else? Maybe these were the only tables that we created till now. Now we are noticed that we are not persisting the news feeds here at all. Does it make sense? We are not persisting the news feeds here at all. Can we do that? Yes, we can still do that. So what we can do? Let's say we do have, let me write that with a different color altogether, because I just want you guys to appreciate that even if we have it, that is going to be a very, very offline process and not an online process. So let's say I do can have a snapshot of news feeds. What does that mean? So maybe I can have the latest news feed that I created once every day. So let's say before so try to understand. So after every periodicity, or let's say before you remove some news feed from the cache, or let's say before you, after every periodicity, you can actually take a snapshot of the news feed and store it here. Because let's say if some user is coming back after a long time and you don't have any news feed to show, then that may be a slight difficult issue to do. But for now, let's assume that we don't have any such table. But I have given you a sense that yes, you can actually have a table which only stores the snapshots. So it need not be an online process. It can be an offline process. Does that make sense to everybody in the class? Does that make sense to everybody in the class? Right, cool, cool. Now, yeah, for each user. Yes, Nikhil, for each user. Yes, Sankalp, we can have a cron job to do that. Okay, cool. But the cron job should be such that it keeps the things distributed. You cannot have, let's say, at 9 p.m., I would want to sync every person's news feed to the DB. If you do that, then at 9 p.m., Facebook would go down every day, right? So your crons here or your frequencies should also be such that those are distributed. Okay, so Sukanya says for each user means 2 billion rows. No, Sukanya. So for each user here, I mean every person who was active at that day, right? Snapshots are heavy most of the time. Snapshot in general simply means that there is a time series going on, but there is something which changes with time, and you just at any given point in time take a photograph of how the curve looks like. Okay, does it make sense? So snapshot is just taking a photograph at any given instant of time of a time series data or of anything which moves with time. Okay, so you can just take a snapshot. Let's say at 10 p.m. in the morning, the newsfeed of this user should be looking like this. So that let's say the user comes back after several years, or let's say after several months, and there is no data. I do not have any of his data in the caches. Then I can just pull it up from the DB and show it to him. But the problem is a bit simplified, because I will explain to you why the problem is a bit simplified, but just hold on for a minute. Okay. So for now, do not get confused with this. Even if you do not have any such thing, it's equally a good design, right? Cool. So now let's come back. We had this global cache, we had this cache. Now we also have a app server cache. We also have a app server cache. What do we have in the app server cache? In the app server cache, we have user ID to the latest news feed that we have. Does it make sense? User ID to the latest news feed that was computed. Understand that this cache is just like throwing masala to your food, right? Your food is prepared. Even without this cache, everything will work fine. But whenever you see any process being repeated again and again, so let's say there is a user named Neeraj who accesses Facebook from his laptop, then he wants to access it from Lokesh's laptop, then from Manish's laptop, and then from Nikhil's laptop, and so on and so forth. He keeps on accessing Facebook from different laptops at the same time, let's assume. So you would want to then cache, just because you see that request being repeated multiple times, you would want to cache it at your end. Does it make sense? And now this cache is again going to be a LRU cache. So you are not going to see the newsfeed cached for every user. Does it make sense? You're only going to see the newsfeeds cached for the people who are accessing that newsfeed so many number of times at that given point in time. Does that make sense to everybody? In the app server cache, do you guys also remember that we had user ID to friend IDs mapping? Cool. Now there is one more cache that helps us, which is the client side cache. So in case of websites, in cases of websites, you are actually going to have a session based cache. That is, till the session is in place, you are going to see a cache there. So let me just write a client side cache here. In the cases of Facebook mobile apps, you're going to have a cache which sits there till the time you have your app there. So even if you are not connected to the internet, you can just come and in fact access the last newsfeed that you accessed. Okay, cool. Then there is also going to be a thing like CDN, which is going to serve you media like videos and photographs. Does this make sense, people? So how will a write post happen? How will a write post happen? Let me just use green pen for write post. So what will happen? You will want to write a post. The load balancer will take you to one particular box where you are sitting. Then you would have to process that post in the DB, right? Process that post in this DB, update these two tables, and then bring that post also to the cache and bring that post also to this cache. Does it make sense, everybody? Now let's look at how you are going to look at a news feed. So let me use not a red pen, maybe some other pen there. So let me just use a blue pen. So read news feed. What will happen? So you, first of all, whenever you open, the first newsfeed that you will be seeing will be from the client side cache if you have a newsfeed there. Does it make sense? This is the first thing that you are going to see. The first newsfeed that you are going to see is from the client side cache. Does it make sense? Okay, so Nikhil asking a question. Nikhil, do you want me to unmute you before I move forward? Because that seems to be a very, very basic doubt. Sure. So let me just unmute Nikhil. Hey, Nikhil.
Yeah, hi Taru. So yeah, basically that doubt only. So here we won't be writing to all the other friends' posts, right?
No, we are not writing anything to friend, right? We are only saying that I made a post. So just add a post in front of my name.
My name, yeah.
Right.
So that afterwards we can use.
Right. Okay. Does it make sense to everybody? I am not doing aggregations at the time of writing. I hope it makes sense to everybody, right? Now let's actually read newsfeed. If you want to read the newsfeed, the first newsfeed that you see happens to be from the client side cache. The second newsfeed that you read happens to be, let's say now you're going to be directed to your particular box. And if you have a newsfeed here in the LRU cache of the app server box, this is the second newsfeed that you are going to see. Does that make sense? Okay, so Sankalp says by client cache we mean it the browser one. Yes, Sankalp. So if you are accessing Facebook website, then a browser, the client is a browser. If you are accessing Facebook app, then the client is a mobile app. If you are, let's say, accessing iOS app, then the client is an iOS app. Okay, good. Now the third thing that happens is the moment your load balancer gives you that response from the cache, in the meanwhile your box is going to make a call to your cache, and the box is going to get the latest posts after a particular timestamp from all your friends. Does that make sense? Does that make sense, people? Now, once you aggregate all those posts from the cache and also from this, so that you know what exactly to serve. Now, what you can do, you can essentially update your latest newsfeed and update this in this cache. Does that make sense, everybody? Now you update this in this cache. So now the next time a refresh request comes, you are just going to respond back with this and repeat the same process here. Does that make sense? And the refresh request can be of two types, folks. Refresh request can be a forced refresh. So let's look at the refresh requests. अरे ये क्या हो रहा है? Can you guys see the screen? I don't know why the iPad is being used. Good. Yep. So refresh requests can be of two types. Yes. Oh, bad color. I'm going to repeat it. Just a minute. Okay. So refresh requests are going to be of two types. One is going to be, let's say, a forced refresh. So let's say you are the one who is actually pulling back the back. So do you do that? So do you actually just try to bring, what do we do? We actually refresh it ourselves from the app, right? So this is one kind of a request. The other is that the client can itself send a periodic refresh request. Okay. So a periodic refresh request from the client. So all of them, yeah, push and pull. So this would be pull, this would be push from a, this would be pull from a client's perspective, and this would be push from a client's perspective. Cool. So now we have understood it, how read post happens and how read newsfeed happens. Does it make sense to everybody in the class? Any doubt till this point in time? Yes, no, cool. Okay. Now let me just read some. Lokesh has a question. Global cache will have some limit. Okay, okay, we will look at it. Now Bodhitwa says global cache has today's. Okay, okay, okay. I will look at it. Now let's say in case of, okay, so Sukanya, push and pull are simple mechanisms in system design. Push means that you are actually pushing something yourself without somebody requesting for it. Pull means that there is somebody who's requesting for that data and you're responding back when somebody requests for it. Does it make sense? So Kanna, does it make sense? Okay. So here forced refresh would be that the user himself or herself want to have a refresh and look at the updated news feed. So that would be a pull. That user is pulling data. Push would be that the user did not do anything. The client itself have pushed the updated thing at a fixed interval of time. Does it make sense, Sukanya? Cool. Makes sense. Now let's actually discuss how we can share a post. Would you guys want to discuss that? Cool. So let's actually see how we can share a post. Let me just use any other pen. Let me maybe use this pen. Very similar. So when you share a post, okay, when you share a post, what happens? So your client wants to actually share a post. So he or she must have seen a post, only then he or she can share it, right? So once they are going to share it, they are going to send the post ID that they want to share, right? So sharing a post is just like creating a post, but with having a parent post ID. Does that make sense? Does that make sense, folks? Right. So when you want to share a post, you are just creating it, but creating with a parent post ID. So you will send the load balancer the new post. You are going to update that new post in your particular, in that cache with a new user ID and a new, with the user ID and the new post ID. And here in this cache, you are going to actually have that post ID and a corresponding parent post ID and the text and so on and so forth. And you're also going to persist that in the DB in the table in these two tables. Does that make sense to everybody? How simple is it to just, okay, cool. Now let's come maybe to delete a post. Okay, let's come to delete a post. So deleting a post would also be fairly simple. You would want to remove that post ID from the global caches, and you would want to have a system where you can mark that this post was deleted. Okay, so in these tables, maybe you can just have, maybe in this table you can just have a column which tells whether it's deleted or not. So you just update it and mark it deleted, and maybe you can have somewhere here again a cache which talks about the latest deleted posts. Okay, so why is that important? Because when you are actually sharing a predefined newsfeed, a newsfeed which already existed, you may be sharing with them some posts that were deleted. Does it make sense, guys? Does it make sense? So you would, okay, why not remove it from the DB permanently? Okay, so do you think that internet companies ever want to delete data? So Moez, you have given me some data about yourself. Would I ever be deleting it? Most likely not, right? But yes, if there is some agreement that bounds you to delete it, then you will be. So yes, you can act, you will be having both kinds of deletes, soft deletes and hard deletes as well. And in most of the cases, you will be doing soft delete only. Hard delete is just when you are bound by some legal framework and you want to do it. Does it make sense, everybody? Okay. Okay. So Samir is now wanting to discuss about comments. Let's not discuss about comments at this point in time, Samir. That will sort of make this a bit more complex, right? Yeah, we can discuss about that, Deepika. That's very, very important. We can discuss about that. That's very, very important. Okay. Okay. Cool. So Sukanya, now let's look at try to think of some boundary test cases. So Deepika, I will be doing that. Just wait for some time. And now let's try to think of some boundary test cases where you feel the system will fail. Are you guys with me? Let's try to look at some boundary test cases where the system will fail. And you guys tell me what those boundary test cases can be. So maybe Sukanya told one or somebody else told one, that what if a user signs back after a month? Okay. Or let's say, what if a user comes back after 1 year? And it's safe to assume that for 1 year, if the user did not come, then you are not going to have anything about that user in the cache. Is that safe to assume? Yes. So I can just replace that 1 year by saying a time after which nothing remains in the cache about that user. So what happens then? This is one boundary test case. Think about some other boundary cases, people. Think about some other boundary cases. Okay. So Bishali says, what about a new user being added? So a user just came and he did not have anything in the cache. Then what will happen? Okay. Abhishek, you're absolutely right. Deepika, you are absolutely right. Okay, deactivate and activate account. Deactivate and activate account is not a boundary case, Archit. It's more of a feature. So let's not discuss about that. Vishali says, user with no friends, a very, very sad person indeed. I feel sorry for that. But if a user is there without any friends, then what would his newsfeed look like? That's not a boundary case. That's basically a okay. Suggest him friends. Okay. Okay. So let's not also discuss that. That's also a feature and not a vote. Okay. Cool. Mark Zuckerberg will always be a friend. Okay. So have you guys seen those memes? Have you guys seen those memes? Okay. Let me just share a meme with you. So, okay. So you did not reply to my messages. What happened? So I slept early yesterday night, right? The girlfriend replies, I slept early yesterday night. And then Mark Zuckerberg says, she slept early? Really? Okay, maybe I should not have said that, but yep. Cool. So these are the two boundary test cases. What about, no, the meme was in fact even better. The boy says that I saw you online. You were still online, but you were not replying to my messages. So the girl says, "Arey, the app was internet. When the internet is on, then it shows online." And cool. Yep. So, okay, let's get back. I'm sorry. Yeah, let's get back. The third point, which is again a boundary case, is that when there is a user who is trying to do infinite scroll of his or her news feed. Does that make sense, everybody? Does that make sense? So if there is somebody who's trying to do infinite scroll, what does that mean? That means that you are actually trying to go out of the limits of cache. Does that make sense? You're trying to breach the limits of cache and then trying to see what happens there. Okay. Can anybody think of any other boundary case? Can anybody think of any other boundary case? Cool. So who would want to answer these boundary cases for us? Anybody who would want to answer the first boundary case? Okay, so Chauhan says, what if the cache goes down? So you can assume the answer to this would be, Chauhan, that you can assume that your cache has some redundancy, has some replication. So that is very, very low probability that everything goes down. If everything goes down, then maybe there is nobody out there to access the system also. Right. Infinite pulling to refresh. I have written that, Sukanya. How are we going to handle global cache write call since there are a lot of requests to global cache? Okay. So Santan is saying that how we are going to write to a global cache, because there are lots of cache writes being happening. Right. Makes sense. So Santan, the cache is also going to be a distributed cache. Does it make sense, Santan? It's not going to be a single box where you are actually going to have that cache. So it's a very, very good question from Santan. So Santan is asking that how is that global cache going to maintain all these writes? How is it going to support all these writes at the same time? Because everything you are writing, every post you are writing in the global cache. Is the question clear to everybody in the class? Yes. The answer to that would be that that global cache is not sitting at a single box. It's also a distributed cache. Okay. It's also a distributed cache. So you can assume it to be something like a peer-to-peer network where every box is allowed to take a write request. And once they take a write request, then they do some kind of syncing amongst themselves and distribute that data across all the boxes. Yes. Okay. So Deepika, let's not call it sharded. So yeah, it's again a distributed system. We are going to discuss how to build a distributed cache in one of the further classes. So let's not worry about it at this point in time. But yes, it's a system in itself. Try to understand that distributed cache is a system in itself. It's not a single box who is caching everything for you. Okay, cool. So that was a good question. Good that you asked it, Santan. Okay, now who would want to volunteer and answer for the class that what happens in this first boundary test case? Who would want to volunteer? Anybody in the class would want to volunteer to explain the first boundary test case? Okay, Lokesh would want to do it. Let me unmute Lokesh.
Hello.
Hey, Lokesh.
Hello.
Hello.
Yeah. If the user will, can you hear me?
Yeah, we can hear you.
Yeah. Actually, when a user will come after 1 year, so we will not have any data in our app server, right?
Yeah.
Not its friends or anything.
No. Okay. So we will not be having, let's say, in the cache, the user ID to friend ID mapping. That's right. We would not have that mapping. Yes.
So we will request for that first.
We will request that for that list from the DB. So now we have got all the friends of that user in just one single DB call. 50 milliseconds is the time that we discussed in the last class. So just in 50 milliseconds, you now have got all the friends of that user. Now what?
Now I will receive all the data from the global cases itself.
Yeah. So the point exactly is, even if a user is coming back after 1 year, his friends' data would still be present in the cache.
Yeah.
Does that make sense, everybody in the class? Does that make sense to everybody? Try to appreciate that even if the user comes back after a lot of time, some of his friends' data must be in the cache, but some of its friends must be active. Okay, so this in itself is not a boundary case, because even if the user is not there, we will just fetch his or her friend list And now the friends, whatever the friends have posted in the last period, for whatever period we have the cache, we can generate a news feed from it. Does it make sense to everybody? Okay, so thanks a lot, Lokesh. This is what you're answering, right?
Yeah.
Okay, thanks a lot. Thanks a lot.
Thank you.
But now we can actually figure out another boundary case where the user was not there and none of the user's friend was also active. Okay. Neither the user was active, neither any of his friends were active. Then it becomes a real boundary case, because now just because the friends data is also not there, you would not be able to generate a cache. You would not be able to generate a newsfeed from the cache. Does it make sense? Does it make sense, guys? Okay. Now what will happen? So to handle those kind of scenarios, let me tell you that these caches are generally, also generally hierarchical. Okay. You can actually go back to, and fetch some data which was slightly older, but still this is a problem which just keeps on repeating itself. So do not try to solve it that way. What Deepika said is absolutely makes sense. Deepika says that he will be shown the popular pages that are around at that point in time, or the sponsored content that is around, or maybe some pages that I would want to suggest to him, and so on and so forth. So till the meanwhile, I actually collect the data from the DBs and generate a news feed for him or her. I can fall back to this kind of approach. Or if I have a snapshot of his news feed, I can pick it up and show it to him till the time I actually compute a new news feed for him. Does it make sense, everybody? Does it make sense to everybody? Now, these kind of things, yeah, it will take a lot of time. Exactly, Lokesh. It will take a lot of time. It will take a couple of seconds to do this. And also, even if it takes a couple of seconds, so we did estimate last day, right? We did estimate that it is going to maybe take 2 minutes or 1.5 minutes, or if you have some concurrency, then maybe 50 seconds or 40 seconds. But that's still not the problem. If a user is coming back to my platform after a year, I can make him wait for 2 minutes. That's not an issue. But the issue can arise if there are so many users who are just logging back in today. Does that make sense? So let's assume there were so many users who were inactive for so many days, and now they are coming back to my system after a year. I don't know why, what's special in today's day, but somehow they are coming back today. If that happens, do you think my network can be choked? Right. Do you think my network can be choked in that point in time? In that case, to handle that boundary case, you actually can use message queues. You actually can say all these kind of requests when I want to fetch something not from the cache but from the server, from the DB. I can actually maintain a queue for it and insert that request in a queue, and the queue will be working on a fixed bandwidth. That is, the queue is not going to consume a bandwidth more than that I've allowed it to consume, and in its own leisurely time it will populate the data for me. So I am fine with people who are coming back after a year to wait, let's say, for 5 minutes, for 7 minutes to get their updated news feed. In the meanwhile, I will show them some random bullshit so that my network as a whole does not suffer. Does it make sense to you guys? Okay, I can repeat it. How many of you it makes sense? This is again a very, very interesting concept. You guys must know this, that how to actually make sure that one issue in the system does not lead to cascading issues, right? Just because some users are back today, that should not inhibit the good performance for the users who are already here. Does that make sense, everybody? Cool. I would just repeat it for the sake of completeness. I was saying that let's assume there is a user who actually comes back after a year. If the user comes back after the year, newsfeed generation will not have much of an issue, because you will just fetch from the DB the friends of that user, and then you can assume that some of those friends must be there in the cache. Does this make sense to everybody? That if a user comes back after a year, that should not be a big issue, because the friends would still be in the cache. And while generating the news feeds, it's the friends data that is important and nothing else. Does it make sense? Does it make sense? Okay, cool. Now the second problem was that what if my friends are also inactive and they were also not present in the system for the last year? Now, in that kind of a scenario, what will I do? In the meanwhile, till I actually compile their data from different DBs, and it will take, let's say, a couple of minutes. Till that time, I will show them some random things, maybe some popular groups, some popular posts, some friend suggestions, and so on and so forth. Or maybe the last snapshot that I have of them in my DB, I will show them then that. But this is not a problem because that user can afford to wait for 2 minutes. But the problem can cascade if on a particular day you see some millions of users coming back after a year. If you see millions of users coming back after a year and none of their data was present in the cache, now your network will be flowing, will be overflowing with all these requests across all these DBs. To make sure that you actually have some order and do not allow these users to overflow your network, what do? You actually queue their requests in a queue and do not allow them to make sync calls. Do not allow them to make direct calls, but instead queue their requests in a queue. Does that make sense? Does that make sense? Now you can have some consumers in front of this queue. You can fix that these consumers there are only 3 consumers, let's say. So no matter how many requests are coming, the consumers are only 3. So they are only going to take their own time. And at any given point in time, I'm only going to have these many K simultaneous requests. Does it make sense to everybody? Okay, so Sukanya, don't get confused. By message queue, I only mean to say a queue where you have some producers and some consumer. So you can very well call it a message queue. Okay. Okay. Yeah, Beshali, we have actually rate limited this operation just because we are not allowing this operation to be freely flowing, and we have rate limited. We have said that we are giving you a specific bandwidth. This operation is not going to take more than that bandwidth. Does that make sense, Beshali? And does that make sense to everybody in the class? Yes, it does, right? What if it's more than K? So Sukanya, this K is determined by you. So no matter how many requests are coming, at any given point in time, you are only processing K concurrent requests. This is what I mean by saying a K here. Okay. Yes, we are not rejecting any calls, Beshali. Every call is getting queued. Okay, but it may be possible that some requests will take 2 hours to serve. No, that won't be the case, Lokesh. The point is we just want to make sure that this does not eat up all the bandwidth. First of all, having a scenario where 1 million users come back after a year is very unlikely. Even if that happens, what will we do? We will for that time maybe increase the K and maybe try to finish this queue quickly. But it is just a way of policing and saying that this operation is not going to take bandwidth beyond this. Does it make sense, Lokesh? Okay, what if the requests are greater than the size of the message queue? Okay, so that is why we have DevOps for. Okay, so DevOps are the ones who actually make sure that that they actually see that, okay, the data is incoming at this rate. What happens if the queue goes out of size? Should I add more boxes to support more data entries in the queue? Should I add more consumers? So these kind of decisions are taken by DevOps in any of the teams. Does that make sense, everybody? There is no crystal clear solution to it. What happens if the queue becomes full? You have to do something there to manage that kind of a scenario. Cool. So I think we have discussed enough. Can queue be distributed? Yes, Sankalp, queues are distributed in several cases, but let's not go into that at this point in time. Okay. What are the trade-offs that we are having in this design? So Samir, we actually discussed the trade-offs while we were designing. So here you would see that we have traded, we have preferred not having so many writes versus, and we have traded off the quick newsfeed generation. Earlier, if we actually have do all the writes and update all the news feeds, it would look like a system where there are so many writes, but fetching newsfeed would be very simple, Samir. Does it make sense? Because then fetching newsfeed would be something like that you have every time you have the updated newsfeed. So that time would be reduced. But here we have decided to take a call that yes, we are fine with taking some time in actual newsfeed computation. Till that point in time, we will somehow engage the user and make him or her feel that yes, we are totally fine. And before he or she notice, we will give him the latest newsfeed. So we have taken this trade-off here, just because we wanted to avoid so many writes. Cool. Does it make sense to everybody? Now let's do some calculations and see for how many days can we actually cache data. Does it make sense, guys? Is that very important to do? Yes, that is very, very important to do. Let's actually try to do that computation. So from what I remember yesterday, we have arrived at this number that we are essentially making 2 MB of data per second. Do you guys remember this, or do you guys want me to compute this again? If you want me to compute this again, I can do that. But if you remember, I can skip it. Should I compute it again? Yes, no? Okay, let me compute it again. Okay, let me compute it again. So let's start again with daily active users. So we have daily active users. How many we said? 400 million, right? Daily active users. Now we said number of posts per day per user is 2. So total posts would be 400 million multiplied by 2 per day. Does that make sense? Okay, did we compute for 200 million? I don't remember. Should I change this 400 million to 200 million? Okay, so let's do that. So let's say daily active user 200 million multiplied by 2. So that becomes 400 million. Is that right? 400 million posts per day. Now let's try to compute number of posts per second, because we compute everything per second, right? In real systems. So we are going to say 400 million divided by 86400. This is going to be somewhere around 4,000. So 4,000 posts per second. Any doubt about this, guys? Any doubt about this? Now we need to estimate size of each post. So any post is going to contain a list of characters, right? And some links to the videos, to the URLs. Okay. So we assumed, yes, Moise is absolutely right. We assumed roughly 500 bytes per post. So total data being written per second is what? 4,000 posts per second multiplied by 500 bytes per second. What does this become? This becomes 4 into 5, which is 20, 2 into 10 power 3, 10 power 5, 10 power 6 billion, which is nothing but, which is not bytes, which is nothing but 2 MB per second. Does that make sense to everybody? 2 megabytes per second. This is the amount of data that you are saving. So imagine at Facebook scale, they are generating more than 2 billion to 2 megabytes of data per second. Isn't that too much, guys? Isn't that too much? Okay. So if we are generating 2 megabytes per second, let's try to look at the data that we are going to generate per day. So data per day is going to be 2 megabytes multiplied by 86400. How much this come to? This will be 816 10 power 4. So this will be 160 GB per day. Is that right? Folks, is that right? So, and also notice this is not the entire data. This is primarily the data that you are caching. Am I correct? This is not the entire data. This is the data that you are caching. Okay. Is everybody in the class with me? Anybody feeling confused? This calculation is very, very important. So the caching data that we are generating only for the posts. This is only for the post, not even for the news feeds, right? This is only for the post. So now also appreciate one more thing. If I was, the moment somebody posts anything, if I was updating every person's newsfeed in the cache, do you understand that this data would no longer be 160 GB per day, but can very well get multiplied by a factor of 1000? Right? And that would be too much to handle for a cache if you end up creating news feeds for everybody in the cache. Now somebody will say, we are still creating news feeds in the cache. How many of you understand that we are still creating news feeds in the cache? Do you guys agree that we are still creating news feeds in the cache? We are not creating news feeds in the cache now. We are having those news feeds in the cache. Does that make sense? People, does it make sense? Okay. But that has a different cache altogether. And we can very well specify that that cache is going to be, let's say, of 200 GB. And now I am only going to store those people's news feeds which are most frequently used. Does it make sense? So I will allow my cache replacement strategies to kick in and make sure that the data is still manageable. I hope things make sense. Now let's come back to this, because this is the primary cache. In this entire system, what is the selling point that is going to set you aside from everybody else in the interview? So let's say some interviewer asks you Facebook news feed. What is the selling point that is going to set you apart? The selling point is that you are only storing global cache के अंदर, only storing the caches, and then computing them on the go, and maybe having, just to make sure that the user feels that the perceived latency is low, having some more caches. Does it make sense? This is what is going to impress any interviewer and see that yes, this person knows what he is talking about. Okay, cool. So we have discussed that. Now we know that we are going to have 160 GB of data per day in a cache. A very, very simple, for in these days standards, a simple cache box would be something of the order of, let's say, 70 GB. A box in these days, which is meant to be used as a cache, would be of the order of 70 GB. So in one box, you would agree with me that I can store how many hours of data? Maybe 7 to 8 hours of data I can store in one box. Does that make sense? Does that make sense, people? So if I just use, let's say, 10 boxes, I will be able to store data for 80 hours. What is 80 hours? It is more than 3 days. So you can very well, just by using 10 boxes, you can very well store the latest posts for 3 days in the DB. Does that make sense, people? In the cache, sorry, if I just said DB, I'm sorry, in the cache. In the DB, you are going to store everything. Folks, are you with me? And 3 days is a good number, right? And let me tell you one thing about Facebook. right, Nikhil. So I was about to tell you that only. So Facebook do not use DRAMs for caches. Okay. Facebook actually uses flash drives. Okay. So what is a flash drive? Flash drive is 3 times more, has 3 times more latency than a DRAM. But the storage that you can do in flash drive is much, much higher. People, are you with me? The storage that you can do in a flash drive is much, much higher than a DRAM. The cost is not less, the cost is higher. So Facebook can afford that much cost. So basically, yes, DRAMs are highly volatile, and flash drives would be not that volatile. Okay, but we will be discussing that somewhere down the line in some next class. Maybe some more, maybe SRAM, DRAM, flash drives, I will be discussing that. But just because Facebook uses flash drives, which just makes it 3 times more latency, which is not a big deal, right? So if something was being done in 0.001 second, now it would be done in 0.003 seconds, which is not a very big difference. But with this, Facebook actually caches data for let's say 30 to 40 days in its global cache. Does that sort of look surprising? Yes, it does. So money can buy anything in this world. So yes, they will be able to cache 30, 40 days of data. And now you would say that what is the point of doing anything if I can have these caches, right? So you can say, what is the point of doing anything if I can have these many caches? Then most of the systems that we would be designing would just fit in the cache and we need not have anything in the storage, right? But let's not worry about that. System design still makes a lot of sense, and still not everything can be on the cache, but yes, with money you can actually afford this kind of a thing. But yes, at Facebook scale, it's very important. It gives them a lot of leverage to actually store 30 days of data in a cache, so that the latency should look very, very low to users. Does it make sense? Okay. So now one question that Sukanya is asking, which is very nice question to ask. Sukanya asks that, of course, if you are storing 30 days of data in a cache, you must be storing it across multiple boxes. Without a doubt, we already discussed that. And now when multiple boxes come, you have a choice to make between consistency and availability. Do you guys appreciate that? Because the moment your system, any system becomes distributed, people, are you listening? Are you listening? Yes, the moment any system becomes distributed, CAP theorem would kick in, and CAP theorem actually exists everywhere, but the partition tolerance would kick in, and now you would have to select either between consistency or availability. Now you guys tell me what we are actually storing. We are actually storing the latest post that some people are making. Would you prefer consistency or would you prefer availability? What do you mean by consistency here? Consistency here means that the moment my friend has posted a post, I should be seeing it right away. Is that important? So let's say I am a Facebook friend with Beshali and she posted something. Now let's say after she posted something, I refreshed my feed. Is it necessary that I must be shown Beshali's post? No, it's not necessary. If it was necessary, I would have said that no, I want my system to be consistent. But here, even if the system is not consistent, I'm totally fine. I want to get some news feeds. I want to see some posts. ऐसा नहीं होना चाहिए यार कि तुम मेरे को कह रहे हो कि बैठे रहो, अभी तो हम नहीं दिखा पा रहे तुम्हें कोई भी feed. I'm sorry. So that will make me unhappy. यार एक तो क्वारंटाइन चल रहा है, घर पे बैठा हूँ, परेशान हो रहा हूँ, फेसबुक चला रहा हूँ, वो भी नहीं चल रहा, क्या जिंदगी है, right? So you will feel like that. So not just so that you do not feel like that, you would want to prefer availability over consistency. And even if I see Beshali's post in my subsequent reloads, that's totally fine. But I should be seeing some posts when I reload. Okay. So I hope this makes sense to all of you that we would prefer availability over consistency. Okay. Any doubt here? Okay. So Deepika asked, where do CDN come in the picture for posts like videos and images? Okay. So whenever you make a post, Deepika, and you are actually storing an image, you are uploading an image, right? When you are uploading an image, your image will first of all be stored in the file storage. Does that make sense? Your image will actually be stored in the file storage. Let me just go back to the diagram and show it to you. So let's say there's a file storage here as well. And the moment you upload a media, your file will be stored here. Your post will be, not the post, but your image or the video will be stored here as a file. Now in the DB where I had post ID to post, this post I told you would comprise of, let's say, text, would have links, would have timestamp and some other details, right? So here you would, in that entry, you will add a link to this file storage and say that this is where my photo is available. Okay, Deepika? Now let's assume CDNs did not store my photos or videos. Then whenever somebody would be looking at that video or photo, I would be fetching that from the S3 or from a cache at my end and serving that to the client. But the problem there would be that my Facebook's database can be sitting very far away from the user. Does it make sense, Deepika? Maybe that particular image was stored in the US West Coast, and I am sitting here in India. That image, also because it's a very, very big media file, images are very, very heavy, it will require a lot of time to transfer it over the network. Deepika, does it make sense? So what will happen? Then why storing global cache if it can be taken from CDN? Yes. So I was telling you that you can store the image in the cache if there were no CDNs. If you are going to see them being stored, being delivered from CDNs all the time, then you can avoid storing them in the global cache. Does it make sense, Deepika? So what will you do? You will now tell the CDN, make a API call to the CDN and tell them that, hey man, I want to store this image with you for this amount of time and give me the URL. So the CDN will accept that image, give it the URL, and now I will start sending that URL to the client and not the image to the client. Does it make sense? So now what will happen? When I send that URL to the client will hit that URL. The client will hit that URL, and now it's the CDN's job to get that image to the client. Does it make sense? So let's say that now the CDN will factor in, okay, so this image is very popular in India. I am seeing so many people from India requesting for this image. CDN will make it a point to store that image, a copy of that image in the Indian data centers that it has. Okay. And let's say now it becomes popular in the US as well. And now it's CDN's job to make sure that for the US folks as well, the time that the CDN takes to get them the image is also minimized. And how will it minimize it? It will just store a copy of that image in those data centers as well. Does it make sense, Deepika? And does it make sense to everybody in the class? Okay. So, okay. Okay. So now Lokesh says, but someone is checking its last 1 year old post. We have to read it from file storage again, right? Yes. So if you are actually reading a post which was very, very old and nobody else in this world is looking at it, why would you want to store it in a CDN? You would not. Instead, you would want to serve it from the file storage, and you would have seen that some images or some videos would take more time to load in, let's say, platforms like Twitter or Facebook, whereas some things would load very, very quickly. So yes, you will always have these kind of situations where there are some images that would not be in the CDNs, but if it becomes popular again, it will again be there in the CDN. Does it make sense, Lokesh? If it again becomes popular, it will again be there at the CDN. Now Sukanya asks, why is the client requesting from the CDN the resource, and why is the CDN not distributing the resource itself? So Sukanya, understand, right? CDN is a different system. I do not know who is a client to Facebook and who wants to use this particular image. So it's the client's responsibility to tell me that he is looking for this resource so that I can send that resource to him. The CDN cannot be going on and saying कि यार भंडारा लगा रखा है, हर किसी को मैं image बांट रहा हूँ, just because even when you did not ask me for it, right? So once the client will ask the CDN that, hey man, the Facebook gave me this link and I would want to look at this link. Can you share the data with me? So then the CDN will reply back to that request with the image. Does that make sense, Sukanya? Sukanya, does it make sense? Okay, cool. That's great. CDN will not be CDN furthermore. अरे बाप रे, कैसी मेटा बातें करते हो यार लोकेश? CDN will not be CDN furthermore. CDN will also have a cache. Okay. CDN will also have a cache. So CDN is, as a concept, Sukanya, is a cache, right? CDN as a concept as a cache. We discussed this in the previous classes. I would advise that you actually go through that CDN Pali class and understand it from there, because we are out of time and I still want to discuss a couple of more things. So CDN is global. CDN is faster, or global cache is faster. Okay. CDN would be faster just because it is sitting very next to the client. Okay. Any other doubt, anybody? Can we move to the last thing that I wanted to discuss for today? Cool. How many of you are feeling tired? How many of you are feeling very tired? Okay. Deepika is not. Okay. Sankalp says, let's hurry. Want to finish this very soon. So, sure. So, let just give me a minute. I think the screen is not being shared. It's now shared again. Yeah, cool. One more thing that I wanted to discuss today was, but I did tell this to you guys already, that just because you would want your data to be persisted forever, you do not just store your data here, but you also take a copy there. Does it make sense? Does it make sense? So what do? There is a cold storage layer as well. What is cold storage? Very, very bigger boxes who are designed to store very big amount of data, but are not designed to handle too many read requests. So these are not optimized for read requests. These are optimized for storing huge amount of data. Does it make sense, guys? So what happens? You are going to store, so you are going to have replica. So there are two things here. One is a cold storage and one is a replica. So you are going to maintain a replica here, maybe at some bigger boxes, where everything that you store in these boxes also get replicated there, so that the things are not lost. Okay. But there is one more thing which is called as cold storage. That essentially is that, do you appreciate that this data is always going to grow, that these tables are always going to grow? Do you understand that? More and more users are going to come. More and more posts are going to be made. So let's look at the user ID to post ID table. Okay. Let's look at the, so we are discussing cold storages here. So let's look at the, yes, Neeraj, just like archive storage. So let's look at the user ID to post ID table, or let's look at the post ID to post table. Do you appreciate that these entries are always going to be added in these tables, keep on adding in these tables? Right. We already had these tables sharded. Does it make sense? We already sharded these tables. So some users IDs are here. Some users IDs are at some different box. Some users IDs are at some different box. Okay. So one approach of handling this ever increasing data is to add more boxes. Does that make sense? And consistent hashing will take care of things and will move data from one box to the other. People, does it make sense? Does it make sense? So what I'm saying, what is the problem and what is the solution that I'm proposing? Okay. The problem that I have, folks, is these tables are always going to grow. Okay, always going to grow. One solution would be to add more boxes. Does that make sense? So let's assume previously you had these many boxes. Now let's say the tables are growing bigger and bigger. What do? You shard them again and say here some user IDs from here, some from here, some from here would be removed and a new box would be added. So just like we discussed in consistent hashing, and now you have, let's say, more boxes. Does it make sense to everybody? This is one approach. In this approach, you are adding boxes of the same capability to hold the entire data. But this is a bad approach. Why? Because not all data is equally important. Does it make sense? Why this is bad? Because not every post is equally important. A very good assumption to make here would be that the posts, let's say, that are older than 5 years are less important than others. Is this a good assumption to make, people? Is this a good assumption to make? And just because the posts that are older than 5 years are less important than the posts that are not older than 5 years, let's, for example, assume that, then having equal capacity boxes, having equally good boxes to store all those posts is a bad idea. Does that make sense? Just because some posts are less important than the others, having equally costly boxes for storing all the posts is a bad idea. How many of you appreciate that? That is why we come to the solution 2. So this is the first solution, which is a bad solution. The second solution that we have is cold storage. So what do? The moment we see that the box is getting filled, we run a cron and remove, or let's say we run a cron every day, and every post that's, let's say, greater than 5 years, I move these things here from the present storage to a bigger box, which is a cold storage. And here the access times are going to be very high because this box is cheaper and this box is not optimized for access. Does this make sense to everybody? Does this make sense to everybody? Cold storage, as Vaishali rightly points out, and so many else have also pointed out, is also called as archive storage. Does this make sense? Yes, Sukanya, you're absolutely right. You would not want to delete the post at any cost, because for these companies, Sukanya and everybody else in the class, for these companies, data is money, right? They earn every bit of their money from data. They cannot afford to remove data. They cannot afford to delete data. Does it make sense to everybody? Yes, Manish, AWS Glacier is what is used here in case of AWS systems. Cool. So do we understand the concept of cold storage now? Let me just add one more small point so that I sleep well tonight, assuming that none of you misassumed what I just said. Okay. So let me just add one more point. That point is that this is the problem when the tables are growing because more posts are coming, right? Because more posts are coming. Let's say the table is growing because more users are coming. People, are you with me? Will the table also grow if more users are coming? If more users are coming, can you actually use the cold storage approach? Would you actually want to say that, yeah, I would want to put Lokesh's data in a cold storage because I am feeling cold for him, and I would not want to put, let's say, Archit's data in cold storage? That you would not do, right? So data, you can see that the data is increasing also because of the users increasing. In that case, adding more equally well boxes is the way. Moving some users to cold storage is not the way. Does it make sense to everybody? Have I clarified one mistake that you guys would have otherwise assumed? Lokesh, you're absolutely right. Lokesh says even telecom companies also do it. They store all the call records which are older than 2 years. They store them in cold storages. That makes sense. Okay, Sukanya says, so we cannot push old, inactive, deactivated users to cold storage. Sukanya, that's a design decision that you would want to take, but that's not the norm to move them to cold storage. And it's also not because, also try to understand, for Facebook, if new users keep on coming, do not assume that at the same rate, people will start becoming inactive. Does that make sense? For these growing companies, the incoming users are always greater than the deactivated or deleted users. So even if you start moving the users who are not very active to cold storage, you are not going to solve the problem, right? To solve the problem in the very first way that we discussed, you are actually will have to move some users who are even not at all active, but you will have to move some users who are slightly less active and also move them to cold storage. But that's not a good idea to do. You would never want to move users to cold storage just because they are less active or they were not active. On the other hand, some posts that were very, very old, you can very well move them to cold storage because very few of us are actually going to look at those posts, and most of us are not going to look at those posts. Okay, does this make sense to everybody in the class? Can we end the lecture here? And will you guys follow my request of revisiting the lecture properly again, so that everybody is on the same page and you do not miss out on important things? Cool. So we have discussed. So Vijay says, can we also calculate how much money Facebook is making per second? That's a good question to ask, Vijay. Moez is saying, do we have a lecture on Friday? Yes, we do have a lecture on Friday. Till this point in time, we have a lecture on Friday. Not sure if we actually. So you're talking about a Good Friday, right, Moez? Do you guys want a holiday on Good Friday? Okay, I see no's, yeses, no's. Okay, so cool. I will share a type form with you guys and let you guys decide if you want a holiday or not a holiday. Okay? Makes sense. Cool, everybody. It was a pleasure talking to you guys. See you again in the next class. Bye. Good night. Hope you guys enjoyed it. Okay. Bye. Yeah. Thank you. Thank you, Shubham. Thank you.